So today we're doing the last section of Chapter 8. It's 8-7. It's called 3D Views.
Yes.
And I really don't know how this is going to go, to be totally honest with you. I love this stuff. I took a technical drawing class. It's kind of like the modern-day CAD class my senior year in high school because I had an opening in my schedule that I had to fill with something, and that looked most interesting. And I found I really loved it. I found I was really good at being able to picture like 3D objects and do drawings of 3D objects on paper. And it was a blast. Nowadays, we were just starting back then, so I'm kind of dating myself. We were just starting back then like the CAD programs on computers. My grandpa's Christian had 4 computers in the classroom. There was an awesome teacher, Mr. Visser, and he had some of us like, okay, try to figure out how to use these programs and then you can teach me. So some of us were able to kind of mess around with the programs some. But now that's pretty much how all the drawing is done. It's done on programs, and you can do drawings of like the top, the front, and the side, and it'll put it into like a 3D object that then you can rotate and twist and see from different angles. And they're doing all kinds of cool stuff with it now that they haven't before. Have you guys heard of 3D printing?
Yeah.
Okay. So they have basically what it is it's a printer that'll go through, and I think usually it's plastic. Instead of like putting ink on a page, it'll put like rows and rows and rows of like plastic on something that can actually build an object. And I saw an article a week or two ago saying that they're now starting to build like human tissues or like build replacement parts for people's bodies out of like real live like tissue. So it could be like, okay, I should have read the article a little more closely, but you need a replacement, I don't know, of a certain type of bone or something like that for your ear. They could actually measure up what size and shape does it need to be and actually print the thing. And now they're starting to put them into people. So, but you can buy 3D printers. They're really expensive right now. But anyways, my point is, this is a cool section, and some of you may end up actually applying some of this stuff, because within your lifetime, I think the 3D printers are going to get to be really inexpensive. It's like, oh, I need this one Lego piece to finish my London Bridge.
Oh, yeah.
My dog ate this, and it's like, well, I could print that out, and it's coming. Or I can't find this in my big mess of Legos. I'll just make another one, And your parents are like, stop using so much plastic. Okay, I'm focused.
All those useless pieces I have.
Yeah, but melt them down, make a piece you want. Okay, so our book's going to go through a couple different ways to do 3D views, and we'll see if you end up kind of loving it like I did. But Roman numeral 1 is, they call it a base plan. And this one, honestly, I haven't seen as much. But what it does is it shows what the base shape is and lists the heights of each part. So it shows what the base shape is. And lists the height of each part. So base plan shows what the base shape is and lists the height of each part. And for these, I started to try to do practice drawings as I did my notes and found they were not looking right. So I slurped some images out of the book. I don't know if you want to take a second and try to quick draw it. Can I flip ahead a page? But the book kind of gave us this thing here. And so if you look at the picture, we have, figure out how I make it move. That's how I make it move. So you have like this front side, so it's 3 wide here on the front. So like 3 wide there on the front, and then you're kind of looking at the corner, so then it goes like 2 back. So if you have something like this, I don't know if you want to try to draw it. My drawing ended up pretty bad, but I think you can just kind of get it from the picture. But this angle right here, what does that angle look like it is? How many degrees? 90. If they're all little cubes, that should be a right angle or a 90 degrees. So for the base plan, what we want to do is we want to have something with a 90-degree angle. And you could do like a front and a back like this. I'm going to try to kind of rotate mine a little bit like they did and kind of have it be like, okay, so here's my front edge, and then I have my 90-degree angle going back. And do you agree it's 3 across in the front? So then you have like 3 going this way. So you might want to even just draw the picture if you want. So even though you're not seeing, draw this thing here in green. Even though you're not seeing what we're drawing an image of, you'll kind of just get what it looks like. But then it goes back to, So are you with me that this is like the base? If you were to set it down on a piece of paper, this is kind of what's going to be touching the paper. And now you have to be able to kind of put your head up above it and pretend you're looking down. So when you're looking down at this square, when you're looking just at it from the top, you can't tell how tall is it. You just know kind of like what's the overall shape. But for now, this thing here on the left, like how high is that one? 3. So what they do is they put a 3 there in the top, showing that that has a height of 3. The next one, this one here, is going to have a height of 2. So they put in a 2. In the corner, the height is 1. And then going back, it's going to be 2 and 3. Does that make sense? I wasn't sure people would have trouble kind of like getting their head like up above it and kind of trying to do that downward looking thing. But that's the base plan. There's definitely going to be some limitations to this. What if you have something on a slope? You know, how would you write that in? But for some objects, this is going to work out well. And can I jump ahead to the next one? What's much more common is my Roman numeral 2. Actually, I'm going to jump ahead one more page. And actually, I can fit it right on here. So I do this here. So my Roman numeral 2 then is going to be a top, a front, and a right view. So Roman numeral 2, top, comma, front, and right view. And this is what we did over and over and over when I was taking this technical drawing or this like CAD class. Is what you do is you take and you have your picture here, and you want to try to make your picture fit. Slide it over a little bit. You draw 3 separate pictures. You draw 3 two-dimensional pictures. Then from those 3 pictures, you can put them together to tell what the overall object is going to look like. And what we're going to do is we're going to draw 3 of them, one from the top, one from the front, and one from the right. So I'm going to start with the front. So the front would be kind of like if you're like standing over here kind of looking at this thing. What is it going to look like in the front?
It's going to look like a U.
A U, but how's the U different?
That middle part up there is just going to work.
It's an upside down U is kind of what I was looking for. But yeah, it's hard to describe. You probably could draw it. But do people kind of see what Franklin's talking about? That this front edge is like it goes up, it goes across, it goes back down. Like George, you were saying an upside down U. So then from the front, you just would draw. So I'm going to have my top view be here. I need to get a pen back. So my top view is going to be here. My front view goes here in the front, and then we have a right side view there. So I'm going to draw my front view kind of in that spot. So if I back up. All right, so my front view, we want to have be that U shape. So, but close enough. So. Okay, I'll erase a little bit of that first line. But can I convince you that the front view would be something like that? And our book, because you're just learning, they kind of break it up into the blocks, so they still have like the little lines for the blocks there. Typically, you won't actually have that as you go through and do like CAD type of stuff with it. But can everybody kind of picture that's what the front looks like? The top now, if you could look at that from the top, that's going to be a little tougher. But I think the tricky parts are going to be you're going to see those 2 that go back. You're going to see that one right there. But can anybody picture what the top's going to look like? Go for it, Franklin.
The top view is going to be a normal U. That's what I was thinking of.
Okay, so you're kind of doing the downward before. Kind of. Is it?
Like if you're looking from the top down, then you're going to see that the edge thing is to be just like flat.
Okay. Do they go to the same height? So before, if we were to try something like this here, I'm going to run out of space a little bit. So is this what the top view is going to look like? I'm a little too wide, but.
Have 3 on the 2 corners, 1 in the middle, and then 1 on the
Okay. So which one do I need to get rid of? I think we're saying the same thing, right? That one there? Oops. Yeah. So I didn't leave myself quite enough room for my top view. That's why it looks a little bit shrunk down. But can people kind of picture that we only go back 1 square right there? And this one here goes back 2. So in the top, we'll see 1 going back on the left side, 2 going back on the right.
Do you have to label like there's 3 like layers on
Nope, because when you're doing just the top view, you can't tell the height. So we don't go back to like what we were doing with that base view. We don't go back and put in the 1, 2s, and 3s. So, is that an okay for that one?
Oh.
And now I wasn't sure how well people would be able to envision it. Now the last one's going to be the right view. So you kind of need to put yourself over here on like this side, and you're trying to like look at it this way. And what are you going to see when you look at it that way? Go for it, Amanda. Perfect, an L. How many high does the L go? Okay. 3 high. And how far back does it go? Okay. What do we think? So do we have... Some of this, how do you put it into words? But are you telling me this here or not? One more. I think you were thinking like 2 additional to the back, right? So the right view is going to be something like that. That we have this one right here is going to be kind of hidden behind that brown one. But we see both, so this would be like the brown one is here. Maybe I could do it this way. This is kind of like the brown one. And then the green one is like there. You see the green one, you see the red, you see the purple, and then the blue. Does that kind of make sense what you're seeing when you look at it from the side? Okay. So that's the top, the front, and the right view, which is going to be way more common. Questions on that before we flip to the last one? I don't know why they don't do the left. Probably the left is going to look the same as the right, but I don't know what made them pick the right to begin with. Maybe it just seemed like the right way. But I try. Okay. Hit the last one? The jokes don't get any better, sorry. All right, Roman numeral 3, the last thing. And these come up a lot in the next chapter. This next thing is nets, they're called. N-E-T-S. And I'm guessing you've probably done these before. So when you have a 3-dimensional object and you unfold it, or they give you what would it look like if you cut paper in this shape and then tried to fold the paper together back into a 3-dimensional object. I don't know if that sounds familiar.
Oh, yeah.
This was the one I didn't see that I could easily get out of the book, so we're going to kind of see how I do for drawing it out. But if you were to do an object like this, so I'm going to start with kind of a long, skinny thing here. And then I want the same height extending to the left, but more of a square instead of a rectangle. Put another rectangle there. So kind of 3 identical rectangles top to bottom. That's what it's supposed to be.
Don't you need another one?
Yep. 2 more. So if I put this here, so you're already putting it together in your brain, finding the missing pieces. So you have a shape like that. And that would be if I had an object built out of paper, if you could like cut the paper where you needed to totally fold it flat on the page. This would be the flat on the page thing. And does anybody see what it's going to look like, or how would you describe it if you had to put it in words? Maybe Franklin?
A rectangular prism.
A rectangular prism.
That's how I taught it. Would be like a rectangle box. It's kind of
Okay.
like this one.
Yep, kind of a box that's kind of thin. I kind of go with that. Do you guys want to pitch something in here real fast, Isabel? Oh, yeah, like a cereal box. Yeah, exactly. I was thinking a cereal box on its side, but I guess you could fold it up a couple different ways. I'm going to have it like laying on its side. That's kind of how I had it drawn here. But this is my attempt at drawing what it would look like. But really, Isabel's right on. It's a cereal box laying on its side. So that's what I'm attempting to draw right now. But I had those short parts being kind of like the height. So this would be kind of like one end of it. That's my front view. And if I were to have my right view kind of extending to the back, it's going to be something like that. And then the top edge would look like this. Probably a little bit more square than a cereal box. But can you kind of picture that that's what it would look like? Now what they often do is for the lines that you wouldn't be able to see, if this was a cereal box, you can't see through the cardboard and see kind of those back edges. So the hidden edges they'll do in dashed lines. And I'm going to change my lines to blue because my dashed lines sometimes turn up a little bit weird trying to do it with a iPad. But it'd be something like this here, would be like the kind of that hidden edges of the box. Something like that. So you can kind of see where the back corners are even though you can't see them from this angle. If instead you wanted to draw that more standing up on edge, you could do that too as well. But any questions with the nets? Yeah, of the three, the first one, we don't really use that a ton. The front right, or top, front, and right view, that, especially if you get into like CAD kind of stuff, or even into like architecture, you'll probably use that a whole lot more. The nets is going to come up a lot in the next chapter as we do a lot of stuff with surface area, which I totally get a kick out of. Here's a shape, you unfold it, you get the net for it, then you figure out the area of each section, and then that gives you the surface area or something. I think it's a lot of fun.